In the previous lesson, we've looked at pricing an option based on its characteristics. Another way of pricing options is through this relationship called the put-call parity. Let's learn what this relationship is and how it can be applied to pricing options. Let's first derive the put-call parity for European options. To do that, we need to understand what a protective put is and what a fiduciary call is. We will start with a protective put. Suppose an investor owns an asset that has a current price of S0. We shall assume the asset makes no cash payments and has no carrying costs. The end of the holding period is time t, at which point the asset will be worth ST. Fearing the possibility that ST will decline, the investor buys a put option with an exercise price of X. This put option has a premium of P0. Combined with the value of the asset, the investor's initial position is worth S0 plus P0, which is the investor's money at risk. At expiration, the value of the asset is ST. Based on this value, the value of the put will be either 0 or X minus ST. In such a case, where ST is greater than X, the asset has performed well and the investor will let the put option expire. This means that the investor keeps the asset, which is worth ST. The ending position in this case, where the put option expires out of the money, is therefore ST. If ST ends up lower than the exercise price, the investor would exercise the put. He will sell the asset for X dollars. Under this scenario, where the put option expires in the money, the investor's ending position becomes X. So in essence, a protective put is a strategy made up of a long position in the underlying asset coupled with a long position in the put option. We shall now find out why it's called a protective put. Let's examine the relationship between ST, the expiration price of the underlying, and the payoff of each of these options. The payoff of a long position in the underlying asset is, quite obviously, the underlying spot price itself. We can therefore draw a continuous line with a slope of 1. The payoff of a long position in a put option is slightly more complicated. Recall that the minimum payoff is 0, which is when the underlying expires at the strike price or higher. The payoff increases as ST goes lower until a maximum payoff of X when the underlying expires at 0. If we were to add up the payoffs from these two positions, the combined payoff will follow this orange line. Notice that this is consistent with the investor's ending position, which is ST when ST is greater than X and X when ST is less than X. You can see why this strategy is called the protective put. The investor receives the benefit of unlimited upside potential with the downside performance truncated at X. Let's put this aside first as we turn our focus now to the other segment, which is the fiduciary call. Consider another investor, an options trader. At time 0, this investor buys a call option on this asset with an exercise price of X that expires at time t. At the same time, he buys a risk-free zero-coupon bond with a face value of X that matures at t. The call costs C0, and the bond costs the present value of X, which is X over 1 plus R to the power t. Thus, the investor has invested funds of C0 plus the present value of X. At time t, if ST exceeds the exercise price, the investor will want to exercise the call option. So the investor sells the bond and uses the proceeds to buy the underlying asset. The ending position of the investor, when the call option expires in the money, is therefore ST. If ST does not exceed the exercise price at expiration, the call expires worthless and the bond is worth X dollars. The ending position of the investor when the call option expires out of the money is therefore X. This strategy is known as a fiduciary call. It's a strategy made up of a long position in call option and a long position in a risk-free bond. Again, let's examine the relationship between ST and the payoff of each of these positions. The payoff of a risk-free bond has no relation to the spot price of the underlying at all. We know that the payoff at expiration will always be X dollars. We can therefore draw a horizontal line as payoff equals to X. The payoff of a long position in a call option is slightly more complicated. Recall that the minimum payoff is 0, which is when the underlying expires at the strike price or lower. The payoff increases as ST goes higher. We can therefore draw an upward sloping line after X. If we were to add up the payoffs from these two positions, the combined payoff will follow this orange line. Again, notice that this is consistent with the investor's ending position, which is ST when ST is greater than X, and X when ST is less than X. Now, do you see the similarities between the protective put and the fiduciary call? Both strategies produce the same result. If both investors receive the same payoffs at time t, regardless of the asset price at t, the amounts they invest at time 0 have to be the same. Thus, we require that S0 plus P0 equals C0 plus the PV of X. And we finally arrived at our put-call parity. So how can the put-call parity be used for pricing options? Let's illustrate with a simple example. At time 0, an underlying asset is traded at $90. Assume that the underlying has a call and a put option with an exercise price of $100. The risk-free rate is 4% and the options expire in 3 months, so T is 1 quarter. Discounting the exercise price by 4% for 1 quarter, we get a present value of $99.02. This is the value of the risk-free bond that the investor has to buy at initiation. We can rearrange the put-call parity formula such that all the options are on one side. So, plugging in the figures, we know that the difference between the put price and the call price must be $9.02. This defines the relationship between the put and the call with the same exercise price. So, if the put is trading in the open market at $15, we would expect the price of the call to be $5.98. This is the price at which no arbitrage is possible. If there is significant mispricing between the two, accounting for transaction costs, an arbitrage opportunity will exist. Let's pause for an exercise. Jimmy would like to short a stock, but could not find an avenue to take a short position. Using put-call parity, construct a synthetic equivalent of a short position in the stock. Pause the video now and work out your answer. And we're back. Remember earlier we learnt that a position in a security can be replicated by a portfolio of related securities. We place the position we want to replicate on one side and the rest of the positions on the other side. So here we put minus S on the left-hand side because we want a short position on the underlying. So the other side will be P minus C minus the present value of X. This means that the short position can be replicated by a long put, a short call, and borrowing the present value of X at the risk-free rate. Continuing, Jimmy found out that the stock is trading at $11 and the 1-year put with the strike at $10.50 is trading at $1. The 1-year call with strike at $10.50 is trading at $3. Assuming a risk-free rate of 5% and negligible transaction fees, is there an arbitrage opportunity? Let's plug in the figures to see if the put-call parity relationship holds. The left-hand side is minus $11, while the right-hand side is minus $12. This is a violation of the put-call parity, and therefore there is an arbitrage opportunity here. The put-call parity can be expanded to a put-call forward parity relationship. Recall from an earlier lesson, we demonstrated that one could create a risk-free position by going long the asset and selling a forward contract. It follows that one can synthetically create a long position in the asset by going long a risk-free bond and long a forward contract. Let's go back to our protective put illustration and replace the long position in the underlying asset with a risk-free bond and a long forward. This strategy is sometimes known as the synthetic protective put. So what we introduce here is a long position in a forward which has an exercise price of F0T at expiration, and a long position in a risk-free bond which at expiration can be redeemed for F0T for the investor to buy the asset. If the put option expires in the money, as in this case, the option is exercised and the ending position for the investor is X. If the put option expires out of the money, the option is not exercised and the ending position is the value of the asset, which is ST. Turning back the clock to the initiation, recall that forward contracts, unlike options, do not require any cash outlay. So for this strategy, the cash outlay is only the premium paid for the put option, P0, and the amount used to purchase the risk-free bond. This amount is the present value of the forward price. Since the ending position of a synthetic protective put is the same as that of a protective put, we can concur that the synthetic protective put is equivalent to the fiduciary call strategy as well. So here we derive the put-call forward parity relationship. Observe the similarities with the put-call parity. The put-call forward parity allows us to gain insights into the pricing relationships between the put options, call options, and forward contracts of an asset. And that concludes this lesson on pricing options using put-call parity, which is essentially pricing options in relation to other options. In the next lesson, we shall learn how to price options based on the price of the underlying. See you soon.